Welcome everyone for the APSCE webinar series. Thanks for joining us today for the 38th APSCE webinar series on human-centered learning technologies and multimodal data. Today we have a distinguished speaker, Professor Mikhail Giannakos. He agreed based on a request, and thanks for that. And Mikhail Giannakos is a professor of interaction design and learning technologies in the Department of Computer Science of the Norwegian University of Science and Technology, NTNU. He is also the head of Learner Center Interaction Lab, and his research focus on design and study of emerging technologies in online and hybrid education setting, and also interested in developing new ways for humans to interact with the learning systems. Professor Giannakos has co-authored more than 200 articles and published in the reputed journals. Professor Giannakos have worked on several funded projects. He's also worked as a editor-in-chief, associate editor, guest editor on several international journals. Professor Giannakos is the recipient of Marie Curie Fellowship, the Norwegian Young Research Talent Award, and also is one of the outstanding academic fellows of NTNU. So with that, I welcome Professor Giannakos to give a lecture on human-centered learning technologies and multimodal data. Before that, I want to inform the participants that this event will be recorded via photography. It may be used for the APSCE for the official publication purpose. If you do not wish to be photographed, please email to the managing secretary. Also, for our further APSCE webinar series, please follow us on one of these official channels. Professor Giannakos, I'll stop sharing. You can start now.
Okay, thank you. Thank you very much. You should be able to see my screen, right?
Yes, we can see the screen.
Nice. Thank you very much for the introduction and your kind, nice words. So today I'm going to talk about human-centered learning technologies and multimodal data. But first of all, just for those of you who haven't been to Norway, just a little bit of an idea where Norway is. Norway is the northernmost country of Europe, and it's a long country as you see it in the map. And NTNU, Norwegian University of Science and Technology, has an acronym of NTNU. Might be confusing if you're from Taiwan, because I know you have a university that's also uses the same acronym. Is the biggest university of the country, and it's the technical university of the country. And it's somewhere, we're somewhere in the middle, like the city is called Trondheim. And in the computer science department, we have a little bit of history when it comes to learning technologies. There are, I would say, a lot of commercial learning technologies we have developed in our group. I would say that most of you should know at least Kahoot, which is a famous, I would say, clickers technology, and it's used from several millions of users today. There are also other technologies for language learning, game-based learning that have been developed. So there is, I would say, there is experience in some history behind learning technologies in my department. So today I will talk about a couple of things. Like, first of all, I'll describe what do we mean by human-centered technologies and human-centered design. I'll discuss a little bit on why it's so important for learning technology, human-centeredness, how human-centeredness is established, what are the main processes and techniques we're using. I'll talk about multimodal data and multimodal learning analytics, what these data are and why those data are important for human-centered learning technologies. And I'll talk a little bit about the challenges and opportunities of multimodal data to support human-centered learning technologies. And there are also some ethics and privacy issues we will talk about. So first of all, what do we mean by human-centered technology in general? And I would say that, first of all, human-centered technologies that is designed with the end user in mind. So the main goal is to respond to our needs and desires. So it's far away from technocentric, I would say, approaches. And whether it takes a form of an app, a device, or a website, the goal is always to enhance our ability to achieve our work, our study, our communication, social interactions, and so on and so forth. And we always prioritize the human over the technical design requirements. So human-centered technologies are intuitive and allowing us as users to complete a specific task without the need of reading any, materials or any manuals or doing any training. They're intuitive, and we should think of technologies like, Spotify, maybe Fitbit, but also Kahoot, which they provide solutions to real problems and desires without the need for learning how to use these technologies. So Fitbit allows you just download it, open it, allows you to monitor your activity. Spotify allows you to listen to music, the songs you want. Other food applications allows you to order food, or Kahoot allows you to have a specific communication with the students, and it's kind of a plug and play and full intuitive technology. Now, does it really matter for learning technology? Does human-centeredness matter for learning technology? And I would say it matters definitely as any other application. It's important for any application, and the same applies for learning technology. Like when it comes to having something that's truly intuitive, that you need zero effort to use it, where you want to achieve large-scale adoption and high penetration from your users. But on the top of everything, we're talking about learning technology where the main goal is, I would say, learnability is the main goal here. And you need to, on the top of everything, to allow educators to contextualize this technology in their pedagogy. So if you're lacking human-centeredness, it's very unlikely for this to happen. At the same time, you need to allow learners to develop agency and ownership, which again, if this technology is not lacks human-centeredness, it's very unlikely for this to happen. And obviously there is a process. So let's think of a lecture quiz, which is how Kahoot looked like 10 years, 11 years ago, while it was being tested in with our students. This is how it looked like. And it was the initial version. We were giving, mobiles to students to test it out, to use it, collecting data, to make sure that it's going to be a successful product. One of the reasons why it became a successful product in the end, and you see 1 out of 2 schools in the US using it, is mainly because it managed to achieve human-centeredness. So it's truly intuitive, addresses specific needs, and it's useful and easy to use. And obviously there is a process behind. Behind achieving that, and usually we're utilizing a process called human-centered design or user-centered design, which is a process. It's an approach where interactive systems are developed with the goal to make those systems usable and useful, and make sure there is a focus on users' needs and requirements. And the process is has been standardized. It's an ISO actually. There is an ISO behind. You can see the steps defined by the this particular ISO standard. And briefly, I would say that you need to identify the need of human-centered design, understand and specify the context of use, and then there is an iterative process where you specify the requirements, you produce, or I would say modify the design you have, and you evaluate the design over the requirements you have set. And this is an iterative process until the system meets the specified functional and organizational requirements. And this process is working, has produced some good results. And on the top of this standard, we have seen guidelines and principles for human-centered design. We have seen principles from the Interaction Design Foundation, like putting people in the center, focusing on solving the problem, considering the ecosystemic point of view, not just particular things, having small and simple interventions. We have seen also guidelines from Stanford School of Design that add empathy and ideation in the process, make it a little bit more specific, focus on other important elements. And we have seen more models. There is a lot of work behind human-centered design, and there is nothing wrong. Obviously, there is nothing wrong with these guidelines. They have helped us to achieve certain degree of human-centeredness, definitely. The main question here is, how do we know if technology satisfies our needs? And this is the important point. What is the evidence? What is the evidence do we collect to evaluate the design? So here in this step number 4, what is the evidence we collect to make sure that the technology satisfies the requirements we have set? And I would say, usually, in most of the times when it comes to learning technology, we're utilizing evidence coming from maybe questionnaires, like students, teachers are using the application, the technology, and then they're filling in some surveys. We're collecting data to see how we're doing, if we need to redesign things, and so on and so forth. The same applies with interviews. We're having an interview with the students, with the teachers who have used the technology, and we're trying to understand how was their experience and improve things. There are protocols for observing them while they're using the technology, and we're also using analytics, the log files that so we're kind of monitoring how they use the technology in the end. But there is a but here. And again, what I wanted to make clear is that these approaches, these kind of evidence that we have been collected, helped us a lot for many years to advance and learning technology and achieve certain degree of human-centeredness. So we have seen a lot of successful products. We have seen, of course, a lot of LMSs, probably some of us are using in our universities, where it's extremely difficult to use, even if sometimes the intended use is simple. It's unnecessary, complex. They're not user-friendly, and in my opinion, many of those companies will run out of business actually at some point. But there is a but. We're collecting this evidence. Mainly, we're focusing on what do learners and teachers think when we ask them about something. That's what we're capturing, right? What do they think? So we rely on their consciousness. We rely on their honesty. We rely a lot on things that maybe, I don't know, maybe it's not, there are certain limitations by relying on those things, let's say. And what about temporal insights or insights that are not externalized? So with those data collections, we wait until the learner externalizes their experience, until they express themselves, until they perform an action. This is what about things, when you're reading something, when you're watching a video, what about all these kind of useful insights that might come up, but they never externalize? We're not collecting this information. So an action, we're focusing on actions that are observable. And I would say observable by human eye. That's what I mean here. So, but the thing is, most of the learning actions, the important learning actions, are not observable. When it comes to reading, watching, thinking, those are actions that are probably the most important actions when it comes to learning, but they're not observable by human eye actions. And the last thing is, when it comes to analytics, we capture an action that is completed, but learning doesn't really happen when the learner, for instance, submits the response. This is when the learner has decided that I'm ready, I submit the response, and this is what we capture with the log files, when an action has been completed. So we're kind of missing a lot. We're missing a lot. And actually, let's think, what are the most important elements we would like to avoid or increase in human-centered learning technology? I would say we want to avoid confusion, make sure students avoid confusion or avoid any excess difficulty. We want to make sure we increase engagement when it comes to the way they use the technology. Avoid any excess work or cognitive load. And I would say, in general, what do we want is to avoid states that hinder learning and increase states that are beneficial for learning. This is the goal we have when it comes to human-centered learning technology. But there is a but here. But those states, let's call them learning states, states that are relevant for learning, cannot be directly measured because they are conceptual entities, they're constructs. But what do we know? We know that they emerge from environment-person interaction. So we know they emerge when the learners and the teachers interact with the technology, and they do influence actions by modulating learning and cognition. So it should be possible to infer learning, those important states, by analyzing the unfolding context and learner actions. And my proposition here is that we can probably do it via multimodal data with the use of multimodal learning analytics. Just to say, what do we mean when it comes to multimodal data for learning? What do we mean, or multimodal learning analytics? We're talking about analytics that are about, for, and of learning, that can be collected utilizing different modalities. And I will give an extreme example here. What do you see? You see a child playing a math game. It's using their body to interact with the technology to perform an operation, and we're collecting different data. We're collecting data from the child who wears a wristband, a webcam, the depth camera. There is a eye tracking. So we're collecting all these sorts of data, and the thing is that when it comes to these data, they can tell us a couple of things about learning states. They can tell us a little bit about just a couple of examples here about their attention, about the engagement, about the difficulty they might be facing. And the truth is that there are some, I would say, misconceptions about multimodal learning analytics. And one misconception is that the use of MMLA is something that requires expensive equipment, which I would say the most insightful modalities are not expensive. So camera, audio, or simple skin and motion sensors. Some, yes, might do, but overgeneralizing, saying that MMLA requires expensive equipment might not be very accurate, or that MMLA are invasive, like use invasive equipment that you need to wear, you need to, it really ruins the ecology of the experience. I would say, again, the most insightful are not, again, are fully ubiquitous and we have eye tracking. You just put something bar behind your screen, or a camera, or an audio, and yeah, some of them might be indeed, but most of them are not. And another thing is that MMLA equals to the collection of personal data, which I would say some of them, many of them do not. You collect data about students' motion data, and the majority of MMLA can be used without collecting personal data. Once you know the data features you want, you can collect them on the fly. You can keep things that do not identify an individual and utilize them to support their learning. And of course, the last misconception I think about is the fact that MMLA might require special technical competence. And I would say most of them require the same level of competence needed for analyzing clickstream data. Maybe if you have a little bit of experience with signal processing, it's definitely helpful, but analyzing logs, there is a lot of similarity with analyzing multimodal data. And there are a lot of technologies that they don't give you the raw signal. Sometimes they give you already data in a JSON format, which is very similar to clickstream data. So during the last years, we have done some studies. We have run a lot of studies in my lab, and we have really concluded that when it comes to multimodal data, has the capacity to pursue three complementary objectives. And I'm going to talk about these three objectives and give some examples. First of all, it contributes to rich measurements. So what you see here, you see a child playing a game, and you see there is an eye tracker here, and there is a webcam here. So on the top of whatever we have been collecting with clickstreams, we're also collecting data, for instance, their attention level, where their focus, the areas of focus with the eye tracking, or the affective states with the camera, for instance. So it contributes to measurements. That's one of the contributions we have with multimodal data. So the second has to do with the interaction affordances of learning systems. So what do we see here is the same example, but on the top of the eye tracking and webcam measurements, we see that the child plays the game with their eyes. So we have gaze interaction that has been activated. And of course, that's probably a little bit of an extreme example, but you can use your hands, you can use your body, you can use gestures, you can use obviously your gaze, your head, and everything to interact with the system, which in some there is a lot of benefit when it comes to embodied cognition, especially when it comes to STEM education, and probably not a good idea going deeper there. But what I want to talk is about the third and probably the most challenging objective, which is on the top of rich measurements, on the top of interaction affordances. What do we have? We have that the system will also utilize this information to improve their intelligence. So not only help with enriching measurement data, will not only help with allowing the user to communicate with the system, but will also utilize this information to make the system to adapt it and change based on how the learner is using the system. And let's go and see a little bit of let's go and see a couple of examples actually. When it comes to richness, so this is an example we did like 5 years ago, and what we wanted to find out here is that when it comes to clickstream data, do we get any additional information from multimodal data? So what did we do? We collected data from people playing a game. We collected the clickstreams, and on the top of it, we collected data from EEG, from cameras, from eye tracking, a lot of different data. And what do we do in the end is we collected also their performance, so how much they achieved while they were playing. And we run simple models to predict their learning performance based on the data we have collected. And what do we see here? We see that traditional clickstream models achieve 18% error rate, which means they have 82% accuracy, which is pretty good. But when it comes to multimodal data, you can go up to 6% of error, so you can go up to 94% accuracy, which is a significant difference. So in the end of the day, the models are much more accurate when they use the multimodal data. And it doesn't work. The more data you have, the better. You see, like, the best solution is not the one with all the data. When you have data that overlap, the performance goes down. So I'm not going to get to the technicalities here, but don't think the more the better. This is the more, it's somewhere in the middle. So now another question that comes up is, what about data we have been traditionally collecting with surveys? Can we infer this information we normally ask learners in an unobtrusive manner? And what did we do here is we followed a course that's a group-based learning course, where students work towards a project, and they meet every week, and they discuss the progress, they discuss their actions, and so on and so forth. And we followed 6 teams throughout the semester, and in the end of the session, we were giving them the typical survey, and during the session they were wearing wristbands. And in the end, what did we find? We found that by utilizing the data collected from the wristbands, we can give a very good estimation of their learning experience if we agree that the learning experience is the one they reported, but they reported it after, in half an hour time after they had the experience. So it was pretty accurate, and they did it repeatedly. So there is some kind of reliability there. And the error was 11%, which means that you have 89% accuracy, which means that it's something you can more or less infer without asking them. You can infer their experience without asking them. So, and obviously asking them, it's not something you can do every time. You can't really ask them every time you have a lesson. You can't ask them all the time. While when it comes to wristbands, that's something or similar technology, it's something you might be able to utilize to some extent, let's say. Or if you can couple this with an LMS, with the technology, you think about Fitbit or something along these lines, it's easy for the individual to monitor their learning experience. And the last, another example similar is when it comes to learning gain. So it was a different context. School children were programming a robot, and they were wearing eye tracking glasses. They we had a test in the end to understand which concepts they understood and which concepts they didn't understand. And what did we find out? It's a little bit higher error rate, but in the end of the day, the outcome is the same, that you can more or less have a good idea of their learning gain without having them taking the test. So there are a lot of information we can get that we usually ask them without asking them. And, this has a lot of implications. I would say positive and negative implications, but this is how it is, though. And the last example, when it comes to richness of measurements, the last example has to do with the temporality. And the temporality is something we can't really get, even when it comes to clickstreams. The temporality you get is limited, because you don't get the temporality. You get only data that are being collected when the learner decides to submit something. Let's say that you watch a video, right? A lecture, half an hour. What data do you get? You get nothing. You will only get data if you have a pop-up, window, or if the learner decides to navigate a little bit in the video. But in the end of the day, the temporality is not really there. So what did we do here? We have a game, math game, focusing on geometry and solving some operations here, and school children were playing them. And what we wanted to do, we wanted to identify what are the differences between the various avatar representations. So should we use a puppet? Should we use an arrow or a hand? Should we use their own body to perform the action? Does it really matter, or it doesn't really matter? There are a lot of questions. Those are important questions for HCI, for human-centered technology. And what did we do? Of course, they were playing the game, and the avatar representations were changing from time to time. And in the end, we collected various data when it comes to their focus, arousal levels, fatigue, stress, cognitive load, or total movement. And I don't want to go to details, but there are differences depending the avatar you're using. Some of them are more engaging and or less engaging for children. And this is something you wouldn't be able to know by just asking children or interviewing children. It's something very, very no, I can't think of a child telling you, I was very stressed with seeing, with seeing a puppet there, and I was less stressed when I was using my own body because it was familiar to me. It's very unlikely for this to happen. So bottom line, when it comes to measurements, you can get things you wouldn't be able to get from traditional measurements. So when it comes to interaction affordances, we should think here that this is not a new thing for HCI. This might be a little bit new for learning technologies, but in HCI, we know that multimodal interaction has been there for many years. And now what do we see? We see that multimodal data are being used more and more to power learning systems. So students can really utilize their body to interact with to make a selection, or to decide on an operator, to use their body to solve even solve problems, I would say. And you can see some examples we have here. So by utilizing multimodal data, you're able to power a system. You see the child here that selects whether they want to interact with their foot, with their hand, with their with a card, with a wand, with an object, RFID object. It depends what they want. And here you see them playing and even solving problems. And what do we see? We see that interaction modalities matter, and there are some challenges when you implement them in the learning context, but at the same time, there are certain benefits. And I would say, especially when it comes to STEM education, especially if you want to utilize concepts related to embodied cognition, for instance, then it's of paramount importance that children and learners, adult learners, are not sitting in their laptop or desktop and they kind of interact with the learning technologies, but they manage to use their body. So when it comes to the last, this is the last, actually, I would say the last affordance that, not the last affordance, the last benefit that is allowing learning systems to develop future affordances. And this is, I would say, extremely difficult. It's something we have seen in the past. We have seen ITS, intelligent tutoring systems, trying to utilize, or maybe utilizing multimodal data in order to provide better context and to provide better even content to the learners. I would say I haven't seen a system working well, but I think this is the future. And one of the examples here we see, and what do you see? You see here a pair of AR glasses where we have developed, we have put some sensors, and these sensors allow us, those 5 EEG electrodes actually connect with the open BCI board and allow us, while the learner is wearing the glasses, to collect data about their learning states, some of their learning states, and utilizing this data in order to change the content or change the way they navigate with the learning technology that is being projected in the glasses. And it's not something I would say we're working on it. It's something complex for sure, but this is something on the top of enriching measurements, one thing, enriching having multimodal interaction, second thing, and the third thing is enriching the actual intelligence of the learning technology. And I would say that this connects very well with and it's probably the way towards the third wave of AI in education, which is understanding context. So, and these are some early results we got from a study we published in IMWood a couple of years ago. This is what they really tell us, that multimodal data are context dependent. Many of them, I would say, not all of them, are context dependent and can help us to model the context. Once we model the context, this means that we can that the learning technology can understand the context and meaning. So, and the goal is that learning technology will understand context and meaning and be able to adapt accordingly. And we need to think that such technology, and I think we're really, going towards that direction. Such technology will not only recognize the learning states, but will be able to explain why a student faces difficulties and how it arrived at that conclusion, which is a giant leap. It's a really a big improvement compared to today's, I would say, black box systems. And just if I have a couple of more minutes, I wanna say this because it's important. Although it's something that most of us have thought about. It's extremely important to think about ethics, to think about data privacy. So multimodal data, it's something that we need to consider. And we can't really, obviously, when all these experiments are presented, we have gotten approvals from the agency, national agency. We have collected data in a control setting, and there is nothing wrong about it. But when it comes to large scale implementations, when it comes to democratizing these technologies, then we need to develop frameworks, we need to develop guidelines, we need to develop actually best practices, and make sure that such data, which are much more, I would say, videos, audio, all these kind of data are used properly, and we're not violating any of the guidelines. And I would say most of the studies today take place in a moral vacuum. So there is we're running studies. We're running studies based on controlled studies in the lab setting. So one last one last slide about ethics and privacy considerations is that, on the one hand, we should obviously make sure that we should not put cameras, let's say, in every classroom, or we should avoid this surveillance state idea. But on the other hand, we shouldn't really demonize sensing technology in the context of education and learning. We should reflect and think how ethical is denying using multimodal data when we know that there is a significant potential advantage that might come out, and we also know that in most of the times we can just anonymize such data. Anyway, I think this is more or less what I wanted to tell you today, and we're 1 minute over. There are also most of these things. I will send the slides to so you can have access the PDF, so you can have access to it. And most of the things I talked about, either they have a resource, a link, or they're coming from these books. Yes, other than that, I would like to thank you for staying for participating to the talk, and I'm very happy to answer to any questions we might have. I can stop sharing so I can see that I think there is a question.
Yeah, thanks. Thanks. Yeah, of course, a wonderful talk, and the way you introduced code and the importance of measuring the learner's affective states, learner-centric emotions, and you talked about we can measure this learner affective using the multimodal sensors, and you showed us walk through, multiple experiments. Thanks a lot. And we have a couple of questions. I will start with the first question. You mentioned the utilization of wristband for unobtrusive monitoring, right? So could you clarify how this wristbands measure the learning experience?
Yes, and this is not only about wristbands. This is I would say this is about the this is about more or less any sensing technology. The way of doing it is that you always need to have a ground truth once before modeling the process. So if we agree that the ground truth we have about the learning experience is standardized surveys where we ask students 10 minutes after the lecture about their experience, we use this as a ground truth. And this is what we did in this particular study. And to improve a little bit of and to make things a little bit better, more reliable, let's say, we did it repetitively. We did it 3-4 times, and then we modeled the data we collected, and we tested if the data can predict this particular learning experience. And this is the first step you do. And once you establish the connection, then you can utilize it in the context outside of this particular classroom. So you need to develop the models first, and the models are developed by utilizing the ground truth that you have collected with the surveys. This is, I think, the response to the question. And this is usually when it comes to anything you're doing in learning technologies and AI, is in a controlled settings. You're having a ground truth, you're modeling you're developing the models, and then you use them in the wild.
Yeah, thank you. So other question is that this is question from UC, from Autonomous University of Madrid. And if you had any experience with children with special learning needs using multimodal, data as they suppose extra challenge, right? So yeah.
Yes, and I would say I didn't focus on that, but now since you asked about it, I can say that for children with special needs or special abilities, this is even more important. And the reason it's even more important is because it allows them to communicate, to express themselves in different ways, and especially avoiding, for instance, certain special abilities children might have. And yes, we have run a couple of studies with children with special abilities. We see that the outcome there is the potential there is greater. But at the same time, what's very extremely important is because you cannot overgeneralize. When it comes to running studies with children with special abilities, you need to consider each case as a unique case, and always you need to involve specialists and people who are coming from this particular field. So I don't want to overgeneralize, but I would say that in all of the studies we have run, we have used multimodal data, and the outcome was the potential was greater.
Thank you. There are a couple of questions in the chat. I'll take a couple of them. The talk was truly interesting and informative. The question is, often one modality becomes the significant contributor depending upon the context. How do you handle such cases and ensure fair representation of all modalities? If you're collecting data from multiple modalities, one modality might be the most significant contributor. Yeah.
Yes, one modality might be the most significant contributor. That's true. And in the analysis, you can identify the importance. It's not something you can see which modality is more important than the other. And this is something in the prediction model, there is there are indicators of importance, and that's something that we do in a data-driven manner. So when the connection with the ground truth is much better, we have a good reason to believe that this modality is far more important. And again, I want to make sure that the more data is not the better. If you have data overlapping, the prediction goes down. So you need to have data that have this sense of additionality when you put multimodal data. And this is done in a data-driven manner. So we're not using any theory or experience-based technique for that.
So this question is based on the fusing. For example, if you're using eye tracking and facial expression data, and what methods do you employ to align the fused data from the affective classification? Because both of them have different sample rate, right? How do you fuse the data from eye tracking and the facial expressions together?
Yes, but there is a pre-processing, like cleaning and pre-processing, and indeed there are some technology. There is, in any case, devices that collect data in a very high frequency, and you don't really care in this particular context. They were made for medical uses. But in most of the cases, what you do is you use a sample rate that's makes sense, and you use moving windows. So you use a moving windows technique, and you don't really need to have the same frequency. You can keep analyzing them with different frequency. But again, you see the signal. If the signal doesn't have much to offer, because everything, when it comes to everything, is a signal, and you employ signal processing technique, you need to know what data you want to collect, to compute, what kind of data you're computing on the top of your signal. And this is, I would say, where theory comes. So although we have employed some data-driven techniques where we computationally gotten frequencies and Fouriers and whatever from the signal, at the same time we have gotten most of the measurements coming from theory, saying cognitive load is being computed with this particular algorithm, and this is what we extract. So we judge this in a case-by-case manner. I don't think the answer was perfect, but this is what we do.
The next question is about ethics from two questions. One is from Khalid Khan, another from Elizabeth Ko. It is like, if you're collecting data, we might miss a lot of data. For example, how do we collect data from students with a different kind of disability? If we collect data, how ethical is to get and rely on data only from a mainstream students? We might not be collecting data from students with some kind of disability. Can we rely on the data we collect only from mainstream students? Is it ethical? Also, other question on ethics is that you mentioned that MMLA research and practice are demonized, right? So that's very strong language. I believe it's also the problem of the wide scope of data streams of MMLA. What would you recommend to help people see MMLA, data ethics, and privacy in a more positive light?
Yes. So first of all, I think that what we need to consider that this is an infrastructure. This is a new reality. And any new reality that comes into our life, it has to be regulated. When you develop a car, the car and the roads you're building, they need to be regulated in a way. Or when you develop drugs, they need to be regulated to make sure they do more good than harm. When you develop social media, it might be a little bit later that are regulated after they have been put in use, at least with GDPR and other regulations we have. But ultimately, they were regulated. So the thing is that when you develop an infrastructure, what's important is to regulate it in a way. It has a potential to support the society. It has a potential to damage the society in a certain way. And this is how I see it. I see it as an infrastructure. And why I said demonized, it's because there is no regulation behind. And currently, how I see like most of us, even myself, I see that it's very difficult to use them in our universities, in our schools, because there is no framework, there is nothing in place. So just collecting camera data, audio data from the cameras, they have a lot of shortcomings and limitations. So what I need to say is that the usual process is running studies, controlled studies, collecting data, going and saying to the authorities there is a potential, there is a framework in place, and then it's being used. People understand the risks. I don't think people understand the risks at the moment. So it's a big discussion. At the same time, when it comes to research, it's something we should of course do our research in following the protocols, the research protocols that exist. And the last, I think this is the last point about collecting multimodal data from traditional, let's say in quote, traditional students. I believe that it's not that we have made any selection. Like we are going to schools, university classrooms, and we run studies and we collect data. So the models and the data that we are collected are not coming from typically developed students, are coming from all students. And I understand, and even we have run studies in children, in students with special needs. But I think that this comment is valid, and you're right that it might develop a bias. The same way that if we look in the game development community, algorithms are producing bots with certain characteristics and propagating a bias actually. So I believe that we have the same challenge here of propagating a bias that might exist in our classrooms and in the context we are collecting data. And I think we need to be more careful about it. In this particular phase, since we're in our research bubble, it's less damaging, I would say. But once multimodal-based learning systems scale up and are being used in our systems, then it's a big problem. And I would say the same applies for clickstream data and the way the data have been used for LMSs. There is difference, but it's the same problem.
Okay. So continuing that, I think the next question is from Fridolin Ting. So it seems like due to the privacy concerns, it's very hard to get all multimodal data, like multi-channel data, for example, eye gaze or EEG signals, to our meaningful. So in particular, all edtech companies, will not share this data with you. So apart from you collecting data from your research studies, how do you overcome this issue of getting data from a big, lot data from the edtech companies in multimodal data?
Well, first thing is that I tried to get the data of my students, clickstream data from my students, from my course, from the company we're paying from my university, and I couldn't. So they didn't give me access to the X API. So what does it really mean in practice? It means that they have the data of my students, and for me, I can't get this data to utilize them in a way to support their learning. So I believe that there are fundamental problems when it comes to edtech companies having students' data. And of course, most of these things have been resolved because now in Europe, it's mandatory that you have a data processing agreement between the university and the companies. So, and you more or less get access today. Things have changed a little bit. This was an experience I had 4 or 5 years ago. Now, when it comes to data, multimodal data. So first of all, we should think that of apps that utilize multimodal data, for purposes less important than learning, in my point of view. Let's say Fitbit is collecting personal data, right? And they're collecting it for lifestyle purposes, which is perfectly okay. But then what's more important, and why they're collecting this sort of data? So I would say that there is a need to have data processing agreement that includes not only click streams, but includes multimodal data as well. If we hope or want or think that this is a direction we want to take, it's not going to happen automatically. And it took a lot of years to happen for clickstream data. So for many years, we didn't get access to our clickstreams, the clickstream data from our students. And this was resolved from demanding and data processing agreement. This is the same thing we can do. But I'm not very fond of universal use of multimodal data. So even if you think the game industry, you have specific games, specific tasks where you're using data like gaze. We want to see where the player is focusing to support their shooting skills. So this is something I believe we can do. And we have used some multimodal data when it comes to pilot training, driving training in simulation centers, and we see huge differences. So there is a long way to go, but that's what I think.
In future, you might get it. So due to time concern, I'll have only last question. This is from Professor John Mason from CDU in Australia. I very much enjoyed your presentation. I'm interested in what you have to say about emerging frameworks on human-computer cooperation or human-computer collaboration, given all the recent advances in AI.
Yes, this has to do, a very good question, has to do with hybrid intelligence, right? And how, and I would say that for many years, we have been having systems that require human collaboration, cooperation, let's say recommended systems for learning. This is obviously a very good example where you get a recommendation, you're utilizing the intelligence, you're merging the intelligence of the system with the teacher as an expert, you get some recommendations and you're making the final decision, right? So this is not really completely new thing. Now a lot of people are trying to sell it as the new thing. Yes, I would agree that there are a lot of new elements that have come into play, definitely. And with the use of multimodal data, it becomes even more complex. But when it comes to the important aspects, so who is liable for making a decision, the teacher, or who is, and there are a couple of frameworks for that. And I would say when it comes to human-machine cooperation or collaboration for learning technology, it's something we will see more and more in the future beyond recommended systems and dashboards that do exist today. Let's think that dashboards infuse bias on our decision making, so it's already somehow there, but will become a little bit more autonomous. We'll try to guide our decision as teachers a little bit more, and sometimes we as teachers will have to intervene to change the course of action of a system. One of the biggest challenges I see here is people's competence. So we need to develop educational data competence. This is something important. Otherwise, autonomous systems will either not be utilized because there is not enough competence from the professionals, or if it's being utilized, it will be misused again because there is not enough competence from the professionals. But this is something in medicine, they have done it a lot. So once you go and that's the last thing I'm saying, if you go to the hospital, here or in the UK, they write down the symptoms in the NHS system and they get 3 recommendations. Oh, this person has either this or that. And then you as a doctor use your experience to actually make a decision. So it's something that is being already used somehow in some areas in our society.
Thank you. John, you raised your hand. Do you want to go?
Excuse me?
Yeah.
Oh, I'm sorry, I didn't realise that we could do this. So look, thank you very much for that answer and for a very stimulating presentation, Mikhail, and also Ramkumar. Yeah, really engaging stuff, and I've got a new reading list to pursue now following your presentation. I'm very interested actually in this last question and your response to it. The whole area of you know what you just mentioned there, hybrid intelligence or composite intelligence that we might you know get to as we start working much more closely with artificial intelligence and in all its forms. But you know, more conversations to come, I'm sure. Thank you very much for such an interesting presentation today. Cheers.
Yeah, thanks,
Thank
John.
you. Thank you for your kind words. I enjoyed it as well.
Thanks, Mikhail, for a wonderful talk and passionately answering all the question and answers. Like, we all enjoyed your talk, and there are a lot of to check from your slides and read more. Thanks for your wonderful talk, and I request Lucian to share the thank you slides. Okay, so there's a small announcement about the next webinar, which will happen in July 31st. Yeah, So there's a small announcement. The next APSCE webinar series will be a panel. The panel on smart technologies in education, especially on policies for effective and ethical use. The panelists are Abiba from University of Malaysia, Maiga Chang from Athabasca, Canada, and Lucy Young from Nanyang Technology University, Singapore. So the moderator will be Kazi Omar. Please register for this the panel for next webinar from the APSCE net. Next slide. Yeah, here is the feedback survey form for today's talk. I request everyone to go ahead and scan this QR code and give feedback about today's talk. So thank you everyone for joining us. You can take a photo of this. Thanks, Professor Giannakos, and thanks everyone.